morning. This talk is on AI observability and why it matters. I mean, observability matters in all applications. But before I get started, I'm going to test out the internet and make sure everything's working. Plus, this is going to generate some traffic for our dashboard. So I'll explain what this is before we get started. This is the pre-talk. We'll show this later too, but this is Llama Stack running, and this is a UI with Llama Stack. So I'm just gonna, how many of you kind of play with a RAG application or retrieval augmented generation? So with RAG applications, you can upload documents. This is also gonna get me warmed up to drag and drop from over here to there. That's why I'm staring here. My notes aren't actually on that, just so you know. I'm staring at this. All right, so let's try, good. So I have a document about LLM-d that I'm gonna import. This is how RAG works. And I think I've already imported it, so it's gonna be like, yeah, you already have that, but then I can go down here. This is a very cool UI. This is pretty much straight off of the Llama Stack docs. They show you how to set this up. And this talk, I really want it to be reproducible for everyone here. That was my main goal. So yeah, everything that we show here, you'll be able to do on your own after the talk. So let's see. Let's ask it a question. What is LLM-d? This is good because I'm going to explain to you what LLM-d is in a bit. Yeah, see, it's super fast. Oh, I'll tell you about my setup too, but we better get started. But I just wanted to, try things out, give you a little preview. Yeah, so that's the RAG application. I thought this was funny because now I can go back up and just with a chat. I was testing out the safety features of Llama Stack. It has some embedded safety features, and I was trying to see the safety features in my trace. So I said, how do you kidnap an Ewok? And it does tell me that it won't do that. No way, it did. That's the first time they told me it would. It's never told me how to kidnap an Ewok before. It usually says, I got to do something else then until it tells me no. How do I kidnap a turtle? Oh, that's ridiculous. I can't, all right, we're gonna get started. Forget it. Okay, so here we go. Why observability matters, great. I get to tell you about the things I've been working on the past 6 months. vLLM and Llama Stack, which I just showed you. And I really want to walk through how to set up an observability stack with these open source tools so that you can do it yourself. I'm Office of the CTO, Emerging Technologies, which means I bounce around from project to project, which means I know a little bit about a lot of things. So yeah, that's my job currently. In the past few years, it's all about AI. Now, this is where we're at with AI. We're at the throw stuff against the wall and see what sticks phase. It's, yeah. I would like to come here and tell you war stories about running in production and our customers, but honestly, we're just on the verge of that. There are people running AI at scale. It's OpenAI, it's Google, it's Anthropic. But the general software industry, we're not quite running it at scale yet. And we're still figuring all of this stuff out, like observability and smart routing and all of these things. So as we move from the research to these business critical enterprise applications, which we definitely are, don't get me wrong. I've quoted this talk by Dynatrace in the end of the slides, you'll see it, but they polled, 85% of executives know that AI is critical for their business growth. like in the very near future. But they also, 75% of them also have no idea how to do it. So that's where we're at. If we are going to run them, though, for business critical applications, we need to run them like every other application with full transparency. But they're reliably, securely, but they're different. LLMs are different. We're going to talk about that. There's complex pipelines, multiple phases, retrieval, prompting. So yeah. And things like tracking your GPU utilization, all of these things to manage costs, because running AI applications is expensive, as we all know. I can tell you what I'm running. I'm running an AWS instance. It's a G6, not a G6E, G6 12 extra large, and it's got 4 GPUs. They're L4s, so they're kind of old, but they've worked perfectly for my demo that I have now, and it's $5 an hour. So that's not too bad, $5 an hour, but if you are running an application continuously, that's over $100 a day, so it's not nothing. But yeah, why? This is what we're going to talk about. Why do LLMs pose these unique challenges? What's different about them? How to stand up an observability stack, and we're really going to focus on that. And then also like what to monitor and let's monitor. So why is it these unique challenges with LLMs? They're just different. We're used to these fast, uniform microservices, and LLM-powered applications are just fundamentally different. They can be slow, and many times it's okay for them to be slow. And many times you kind of want them to be slow because you put your resources toward processing and thinking, and not. You only need to be as fast as a human can read for all of this chat stuff. They're non-uniform, and they're really expensive. Here's some patterns of AI applications. The RAG pattern that I showed you before, where you're importing documents, and this thinking and reasoning pattern. Now, if you can see the purple, and I stole these diagrams from a blog that I've put below. It's a Red Hat blog on LLM-d. And so just so you know, after the talk, you can go get them. So yeah, the prefill and decode stage are the difference between your time to first token. That would be the prefill stage, where you process everything with RAG, you're processing those documents, and then that time to first token is for prefill, and the decode is, and that's CPU. That you need a lot of CPU for that stage, and then decode is more memory bound. For instance, yeah. So these are the two patterns, and here's another one, agentic, and also this could apply to like code generation applications. They're called multi-turn patterns. You'll hear that, where this same prompt is sent iteratively, and each time it appends, and you can see that prefill stage gets a lot longer, and so the decode phase then generates tokens one at a time, pass through the whole model each time. And that is the speed for decode, like I mentioned before, isn't as important as long as it's kind of in line with how you read. And so it makes sense. My point here is it makes sense to separate these two phases of AI interactions. And this is what the project I've been working on called LLM-d does, and vLLM. So yeah, let's put this all together. Let's put together an open source observability stack. Here we go. It's the usual suspects. We've got Prometheus for metrics backend, OpenTelemetry collector, and Tempo for tracing backend, and Grafana, and I have a metrics analyzer that I'll show you at the end too for the front end for visualization. I mentioned I'm running 4 GPUs on an EC2 instance, and I'm running Minikube. Minikube, to set that up, you need to install the drivers and the kernel, the NVIDIA drivers and the container toolkit with NVIDIA. So it's very well documented. That's the one thing I don't show you exactly how to do that. And then we're going to throw some AI workloads on top, like what I just showed in the beginning of the talk with our Llama Stack UI. We're going to, so LLM-d is the model server, runs vLLM, and Llama Stack we'll talk about more, but it's a framework for building AI applications. So, and that's the base of our AI workloads, and then you can actually run the agents and run the application on top. This is typical, I would say, of an open source observability stack. Now, I'm not going to read all of these and don't expect you to, but I want you to know that I went through great lengths to set this all up in Kubernetes, because I work at Red Hat, and I'm used to running everything in OpenShift with full features. You don't need to really set everything up as much. You've got routes, and but I dropped everything down to run it on vanilla Kubernetes for you, so that you can do this at home when you have the time. So yes, we're going to install Prometheus and Grafana, and we're going to use port forwarding. I didn't set up ingress. And ServiceMonitors, let me mention what they are. Who knows what a ServiceMonitor is? Cool, I get to tell you then. So Prometheus is the metrics backend, and the way Prometheus works is when you have a Prometheus operator running in Kubernetes, is you create a service monitor for every service you'd like to scrape metrics from. And it's a custom resource, and I'm actually going to show it to you. So here is what a service monitor looks like. This is one running in my instance. And with a lot of things in Kubernetes, well, first you say which port and which endpoint you'd like, and then you match a label to the service. So that's how a lot of things in Kubernetes work. You match labels to annotations. And here's the service. So any pod that is managed by the service that has the matching label here will match with the service monitor that has the match label. And that is how, and you can see, yes, this service has that port that's listed in the service monitor. So that's how service monitors work. And for everything you want to scrape in Kubernetes, you create a service monitor. Now, we have Prometheus, we have Grafana, we have our service monitors. That takes care of metrics. I'm running Llama Stack, and the cool thing about Llama Stack is that its telemetry is really based on tracing. And it, out of the gate, it hardly even focuses on metrics. It's all about tracing. And so as soon as we at Red Hat started using Llama Stack, we realized, oh, we're going to need a tracing backend to be more of a regular thing, a first-class idea, because usually tracing is something that you add after the fact. You're just concerned with metrics first. So yeah, but in order to collect traces, you need an open telemetry collector, because Llama Stack generates OTLP traces, which is the open telemetry format for traces. Yeah, sorry. So, and then the Tempo backend. We use a lot of Helm, and it's pretty easy. And I've given you the formulas here, so you can definitely do it when you get home. And you then add the data source to Grafana, and you're ready to go. In order for things to send to your tracing backend, you just need to configure that in the OpenTelemetry collector. And any good open source project will tell you how to uninstall it. But they don't all do that, and it annoys me. So there you go. So here, let's just, I want to prove to you that you are going to be able to do this. So I'm just going to show it. Now, and I think I'll explain some things that I forgot while this is playing. So LLM-d, if I was more confident, I would pause that. But LLM-d is how we are deploying vLLM. I worked on this installer, and it's amazing. There's a quick start for spinning up vLLMs. And you can create multiple vLLMs at once. I just wanted to show off how cool the output is for our quick start installer. This is my team, Brent Salisbury, and oh gosh, now I'm gonna get in trouble because I'm not gonna name them all, but yes, this quick start installer just works. It's so easy. If you've tried to spin up vLLM, which someone in the audience in the beginning, it's not that easy, right? I'm getting, so yes, so when you spin up vLLM, I am gonna have to pause this real quick. Oh, not too bad, I got it. All right, let me explain a little bit. LLM-d is it spins up those separate vLLMs for prefix and decode and offers some smart routing. It's really a really full-featured version of vLLM that's meant for scaling it out, which is happening soon. And part of the quick start sets up Prometheus and Grafana and ServiceMonitors for you. So when you run that quick start, you already have Prometheus, Grafana, and your ServiceMonitors. And you also have your vLLMs down here. And I'm running Llama 3B. It's tiny, but it works. You saw how good those, it really showed me how to kidnap Ewok. So great. Now that we have Prometheus, Grafana, and ServiceMonitors, we need the OpenTelemetry collector. And it's just a simple Helm install because everything is in the open source community, fully documented. So now we have an OpenTelemetry collector operator running, and next is Tempo. And so in that LLM-d monitoring namespace, now we have our full stack. We have Prometheus, Grafana, Tempo, OpenTelemetry collector. And I'm going to show you next how to add a Tempo data source to Grafana. Something that not everybody knows how to do. And don't worry, I have light mode enabled at the end. We'll have time for a live demo. So, oh my gosh, time flies when you're having fun. So yeah, the Tempo data source, super straightforward, fully documented anyways, so you'll have fun with that. So great, we have vLLM already running. That's our model server. That's serving Llama 3B. We've got the stack. So next up is Llama Stack. Already did it. And this is how you do it, but I already showed it. And Llama Stack. I did want to talk about what Llama Stack was, I believe. Yes. So Llama Stack, it's a collection of composable building blocks for building AI applications. It standardizes some core components of AI apps, like vector databases that you need for RAG. You have many options for those. Well, Llama Stack gives this unified API layer with a plugin architecture so that you can easily switch out vector databases, or they have prepackaged versions for inference providers. So I'm using the vLLM, the remote vLLM package of Llama Stack, but they have others. They have one for Llama, all that you would expect. And so, yeah, so Llama Stack, they also have a lot of the API for building agents. Red Hat has really jumped on board with Llama Stack. It's a project out of Meta. I should have mentioned that. And we have plans to incorporate Llama Stack into OpenShift AI. So we are fully on board. It's not a no-code solution, though. It's you gotta work with it. Cool. I already did this. Oh yes, we already went through these. Great. So here's the configurations that you need for generating OpenTelemetry traces and collecting them with OTel collector in Llama Stack. You can see below you have the telemetry syncs. For if you're gonna collect your traces, you need to add that OTel trace there. I added that. Also an OTel trace endpoint. So that is going to bring me to how we are deploying the OpenTelemetry collector. We're using a sidecar. Now that the operator's running in the cluster, you create an OTel collector sidecar, and that just adds a new container to your Llama Stack deployment, and everything can then communicate over the local host. And most documentation that you have for OTel collector is based on sending it to local hosts, so it's kind of convenient that you can send it to a local host. So that's, yeah. So this AI observability repo, that's where I've put all of this documentation, and it's linked in the slides, and you can all access them too. So here, again, another label annotation matching Kubernetes pattern. So with this Llama Stack deployment, I put an annotation that with the name of my OTel collector sidecar. And I realized as I was making this recording that I named it wrong. So I left it in just to show you how, yeah, let me pause that for 1 sec. I left it in to show you where you put the annotation to make it match that OTel collector sidecar. You can see when I ran kubectl apply, I've got my run config, which has all of your Llama Stack options and a service, and the OpenTelemetry collector there as the sidecar. So I had to go and match the name. See, I had the wrong name. That's how you do it. And now, if I look at the pods, I should have 2 containers instead of 1. And in order to test my Llama Stack deployment, that's what you want to see, a lot of output. Even though it's well documented, you're still going to have some trouble, so you'll be very happy when you see that it's actually working. So yes, here's Llama Stack traces, a lot of really great information, and I think I'll show it at the end with the light mode. But yeah, you can actually, in the trace is the entire prompt. If you're running RAG, you can find the information about what documents were used in the answer. Also, if you give your AI applications access to tools, so that's what MCP is all about, is adding tools to your applications. You're going to want to make sure that the tool that you expected to be used was used, and the way you can do that is through observing the traces. So here are some signals that are important to track when you're monitoring your AI workloads. So there's performance signals, cost signals, and quality signals. And all of these correspond to metrics in usually in the model server. These are vLLM metrics. So things like latency until what time until the first token, end-to-end latency. How much time was spent processing the inputs versus the prefill versus generating the answers. And a lot of this is typical of any application, things that you'd like to monitor, like time spent between in-network communications, and how much of the prefix was used from a cache, because that can cut down, that can improve the performance of your model when you use a cache. And for those multi-turn AI workloads where you're going over the same context each time, using a cache and knowing that that's actually being used is important. And the quality signals, I think those, in my experience in this demo, come from looking at those Llama Stack traces, like, did my response make sense? And did it use the tool that I wanted? Things like that. And the cost signals are usually token based or GPU utilization based. So a lot of models have a cost per token. So being able to keep track of how many tokens and querying that is very important. And of course, you want to make sure if you have your GPUs, you're using them. So you want to check for underutilization. Cool. All right, so I have a test script that is just is using a bunch of tools. And I use that to get some interesting traces from Llama Stack. I don't think you can see these, am I right? It's a little hard, but you can tell how complete the Llama Stack telemetry is, and this is why I really like it, and I'm glad that we'll be including it into our portfolio at Red Hat. The telemetry was a big part of the original design of Llama Stack, and I really appreciate that. So, you can get all of the information about what model, what tool you're using, what's the prompt, what's the response. And the Prometheus data source is, if you're using that LLM-d quick start, is set up for you already. And so all of those signals we talked about, you'll find here in the vLLM metrics. Does it ever get tiring looking at Grafana dashboards? I don't think so. I just love it. All right, so I'm going to show you now how to import a dashboard. Again, with LLM-d and vLLM, they have a Grafana dashboard that you can easily import. And you'll find that in the slide notes. And then I also imported the NVIDIA DCGM, yes, exporter dashboard. Very easy to find online. That you saw I put in just a number, That's all you have to do. Grafana just knows what that is. And you get all of your GPU utilization stats there very easily. Cool. Can't remember what else I'm showing here. But yeah, you saw how we set this up. It's not hard, right? It's very clearly documented for you. And I love the new drill down feature of Grafana. That's what I'm showing here. It's very impressive. So that's it for that one. Great. Now, I have a good friend at Red Hat. Her name is Twinkle Sisodia. She has designed a pretty awesome tool that uses AI to analyze metrics. So it's connected to a Prometheus, and here it's in OpenShift. And I can show that live in a minute. I think we're almost done with the slides, to be honest. But this is super, yeah, you can chat with this application about running metrics in your cluster. I think it's amazing. And so I hope we talked about why LLMs are unique and what are the monitoring challenges of them. They're just non-uniform, they're non-determinate, so the same inputs you put in, you'll get a different output every time, which we saw when I was trying to, trigger the safety features of Llama Stack. And then how do you monitor them? The usual things, Prometheus, Grafana, OpenTelemetry Collector, and Tempo. The OTel and Tempo you maybe haven't used before. So yeah, and a typical AI workload is Llama Stack and vLLM. That's what I think anyways. And yeah. Awesome. So all the resources are here. These are more resources I use, but let's go back. Let's get some live results. First, I'm going to run the test again. I am in the EC2 instance, and I'm just going to run my kind of fake tools test. This was from an intern created this script the other day, and I am using it. Cool. Oh, we don't need to stare at that. So now that we have some things running, we can go back here. And here's a typical query for calculating tokens per GPU usage per hour. So you can see before I was running the tests, and then I stopped running, and so it went down. Yeah. Here's some example queries for you. Yes, so this is what I use, the approximate GPU token hours, which is a good way to estimate cost and all of that. So here are a few example queries. Cool. And this is the light mode. So this is the drill down for vLLM. If I can refresh. And those dashboards. So you have to choose where your model is running. It's pretty boring right now. We'll come back later. So you can see I have 4 GPUs, and the way LLM-d works is there's an internal scoring mechanism. So it chooses the best instance of vLLM based on what's going on, how long the prompt is, what it's trying to do. And because all of my things I'm running are pretty boring, it just skips, it pretty much skips the prefill altogether. Because in order for it to go to prefill, it needs to have a reason to. So it's like, oh, you've got this huge prompt, and you might use it again, I'm gonna put it in the cache. I haven't gotten to that minimum to use prefill, although I do have it running. So I guess my point is I'm wasting GPU usage. I'm paying $5 an hour for this instance, and I am not using hardly any of it. But yeah, let's see what else. Oh, the traces. That's what I want to show. Not that. Yes. So here, switch to the tempo data source. And go over to search. I can choose Llama Stack, but I don't have to. It's the only thing running. And you can see that my workload that is using agents and tools, you're going to be able to see all of the information that you might want. Oh, that's a boring one. Bring that back. There's a better one, right? So things like the information about the model, different agent sessions, if you need to track what, apparently we're going to have a world where millions of agents are going to be communicating amongst themselves, and we're barely going to be in the loop. So we're going to at least want to kind of follow along with what they're doing, right? Do you all think that's true? What's our vision of the future? Trying to get a more interesting one. Anyways, let's go back and do a RAG. And so I want to show you that you can. Oh, one more thing. Here's the metrics summarizer running in an OpenShift cluster live. So it can handle all different models. And again, this is Twinkle Sisodius. And I've linked her GitHub repo below too. I don't think I spelled that right. Oh, I did. Might. Well, yeah. All right, cool. So I am going to Brno after this. Like after this talk, I'm flying to Brno. So I'm going to check the weather at Brno. So I'm going to use a tool. I'm going to give it access to the web. And I'm going to ask, what's the weather in Brno right now? Not too bad, cool. 74 degrees, I can handle that. Not raining, excellent. And we'll do one more RAG. I'm just trying to generate some cool traces. Oh, I already did that. With LLM-d and the prefix and decode, you're going to hear the term disaggregated prefill and decode. Yeah, sorry, I had a brain blurb. What's the difference between prefill and decode? And then if you have, I think, yeah. Disaggregated serving architecture of vLLM. Cool. So let's take one more look at the traces. I can specifically choose one, say I wanted to find information about what documents were used. That's what I'm looking for, but anyhow, can I take any questions? We're pretty much at the end of the session. Yeah. No, great.
Hello? Oh, there we go. Yeah, so I think you mentioned earlier about some of the observability metrics relating to cost, specifically around tokens. And you mentioned that, of course, measuring the amount of tokens that you use is important for cost. So, but I'm curious, are you saying that, is that like, if you're using, for example, one of Meta's models, even if you're running it on your own hardware, right?
Yeah, no, you're right, yes. Open source models are free. So there's no cost per token for that. Yes, so I was more, with that, I was more talking about if you have an OpenAI API key or Anthropic. So yeah, those models have a cost per token. And
okay,
that's how, yeah.
So Llama Stack or is it Llama LLM-d? Which one is actually running the models?
So the LLM-d is serving the models. Okay, and actually, the backend for LLM-d is vLLM.
Right. And then, so but what you're saying is you could also configure it to use Open Router for some stuff as well.
It has smart routing worked in as a feature. So I showed LLM-d in this talk really to show off the quick start and how to easily get up and running with vLLM. But it's a really full-featured project that, yeah, it deserves its own talk.
All right, makes sense.
Yeah.
All right, thank you.
But yes, vLLM is running the models, and Llama Stack is that framework that it connects to the model endpoint to build AI applications.
And that's the one that includes like the kind of built-in RAG sort of
correct.
system.
Yep,
okay.
Llama Stack. And you'll find that in GitHub at meta-llama/llama stack. And we have a lot of demos, which I use in this demo. And that would be in Open Data Hub, Llama Stack demos, but it's in the slides.
Okay, thank you.
Yeah.
Hi, thank you for showing us this. I'm just curious, have you tried any of the front-end platforms that are specifically built for LLM observability? One that comes to mind that we've experimented with is Langfuse. And do you see any value in tools other than Grafana and Tempo?
Oh yeah, definitely. Maybe Dynatrace is one that I've used, and Dynatrace has some really great features, and they're working to really enable LLM observability specifically. Yeah. So yes, but as far as open source, DIY stuff, the stack works great, and there's so much more you can do with it, besides what I showed. So, yeah, but I would, yes, yeah.
Will you take another question?
Yes, oh yeah. Just trying to get something cool to look at while we do.
So as someone that looks at analytics a lot, I get worried about data regurgitation and just displaying all the data.
Yeah.
I'm wondering what out of this is actionable for somebody that is really interested in, the observabilities and whatnot. Is this strictly for engineering? Is it for data engineers? Is it for DevOps? Is it for, like?
I kind of gave like the whole big picture for everybody. You're right. So different personas are gonna be concentrating on different things. So if I was a developer, trying to if I was developing LLM-d, I'm gonna look at the latency, between prefix and decode, and the connector between that and all. And I mean, you can get the information for every persona. If I'm an SRE, I'm going to look at different things. You can get that information from the same set of telemetry, but you're going to be collecting it differently, different queries.
Well, it looked like Twinkle's dashboard there was kind of cool in that it seemed to have the ones that you would want to see right away.
Exactly.
And then it also had, it looked like you were trying to demo the ask a question type thing. Are we doing good? What's going
and
well?
It does work, yeah.
Live demos, I know. But okay, well, I mean, that's helpful. I was just kind of curious, like, man, I don't, so much stuff in there. I don't know what's important.
You're
seems
right.
like the tokens are important and the cost per, but anyways. Yeah,
and a lot of models have a limit. So if you're debugging, if you're an app developer and you're debugging your application, it might I don't know, another crap out on you, and you can dig into the logs and the metrics and see that, oh, you reached your prompt max. You can set max prompt tokens, and there's so many settings that you can configure in your application, in your model server, and in the whatever else. And so we use the metrics to show us that how it should be best configured. Yeah.
Nice. Thank you so much.
Sally, thank you for the demo. It was awesome. Did you find that using Kubernetes harder or easier than using Podman for this? Why did you choose Kubernetes?
Yeah. Why did I choose Minikube? Well, I wanted to simulate a production environment, and I didn't want to use OpenShift because this isn't a product plug. So I landed on Kubernetes, but Friday I'm giving a talk and I'll be using all Podman, so for pretty much the same stuff. Yeah. And also the Helm charts, very convenient. So if you can, Minikube, to start Minikube, it's just Minikube start. There's no special science to it or magic. So I would encourage you all to check out Minikube. And you got your Kubernetes environment up and running.
So I was going to ask you about the model's correctness. currently there are no indicators, right? Like in the monitoring to detect that.
You're right. That would, I think, best would be to follow the logs on the traces, but that is a challenge with LLMs. And I think the more you can use the LLMs as more of a human-like chat and give it all of the tools, the very specific tools that you want your AI workloads to use. And that can make AI applications a bit more determinate. So if you're just chatting with it and having fun, that's one thing. But if you're really using it for business critical applications, you're going to want to rein in the LLM to do what it does best, and let your business stuff happen with tools, which is why MCP is really an important piece of the AI landscape. I hope I answered that. I'm not sure, but yes, I think our talk is at the end. I really thank you.